Welcome to Module 7, Connecting to Your Data. This is where we stop using toy examples and connect Python to real databases safely, starting with SQL Server. The mental model is simple. A database is organized tables, rows and columns, like a spreadsheet that got serious about size, reliability, permissions, and history. To connect from Python, you need exactly three things: a driver that knows how to speak to the database, a connection string that says where it lives, and credentials that prove who you are. Once connected, the loop is always the same. Write SQL, send it over the connection, get rows back, and load those rows into a Pandas data frame for analysis. Start with SQL Server because that is where most of the useful work data lives. PyODBC is the driver. SQL Alchemy wraps it nicely. Pandas reads the query result into a data frame. Trusted Connection is the cleanest path when it is available. SQL Server trusts your logged-in Windows account, so there is no password string sitting in your code. When you do not know what tables exist, use Information Schema. It is the database catalog. List tables, list columns, check data types, and stop guessing. When exploring, peek safely. Use Select Top 100. Do not pull a million-row production table just to look around. NoLock is useful for browsing, not for final reports. Parameterized queries are non-negotiable. If a value came from a user, a form, a file, or anywhere outside the code, do not paste it into SQL with an F string. The reflex is simple. Values go in params, not in the SQL string. The driver treats params as data, never as executable SQL. That is how you avoid SQL injection. Postgres is common for app backends and cloud databases. Same mental model, different plug. You usually keep one database URL in .env and create a SQL Alchemy engine from it. Small gotcha. SQL dialects differ at the edges. SQL Server says top 100. Postgres says limit 100. Same idea, different words. MongoDB is a different shape. It stores collections of JSON-like documents instead of rows and tables. Instead of a SQL where clause, you pass a filter object. Oracle ADW is the deep end. It is powerful, sensitive, and restricted. Treat it as context for now. Wallet-based access, TNS aliases, and guidance before touching it. Secrets recap from Module 6. Connection details do not live in Python files. Put URLs and credentials in .env, ignore that file, and prefer Windows Auth when possible. Cache reads when you build apps. In Streamlit, cache query results for a few minutes so every click does not become a fresh production query against field data. Claude is very good at this plumbing. Ask it to explain a connection string, generate a SQL Alchemy engine, write information schema queries, or parameterize a risky query. These patterns show up in shipped apps. Real projects cache database connections, map messy exports into typed models, use trusted SQL Server auth, and pull from sheets and files too. Try this with Claude. Save your connection profile, generate a SQL Alchemy engine, browse information schema, then rewrite one risky query so it uses params. That is Module 7. Next, Module 8 turns the connection into an app for exploring, summarizing, and visualizing your data.